Hi everyone. This video is a review of our discussion last time regarding parabolas and also a continuation. So let's start with a review on how to graph the parabola given the equation. So the given equation is x squared is equal to negative 4y. If you can still recall, this given equation is or can be compared to the standard form x squared is equal to negative 4cy, right? Now, in order for us to graph this given equation, we need to determine the different parts of the parabola first so that we will be able to graph it later on. So, for this given equation, if you can still remember, if the exponent 2 is on the variable x, that means that the parabola is either opening upwards or downwards. If the exponent 2 is on the variable y, that means the parabola is either opening to the left or opening to the right. Now, for us to determine if the parabola is opening upwards or downwards, we need to take a look at for C. So, if that's positive, that means that the parabola is opening upwards. But if it's negative, that means that the parabola is opening downwards. So, in this case, since 4C, this part here is negative, we know that the parabola is opening downwards. So the first part of the parabola that we need to plot or that we need to determine is the vertex. So how do we determine the vertex? Last time, I gave you a summary of the standard forms of the equations of the parabola. So if we have this standard equation, that means to say that the vertex is at the origin 0, 0. So recall that for the summary, there were two types of standard equations. The first group, the parabola, the vertex is at the origin. The other group, the vertex is not at the origin. So for this form, the vertex is at the origin or at 0, 0. So 0, 0 can be found here at the origin of the Cartesian plane. Next, we need to determine where the focus is. So if you can still recall, for C or C, simply C, that is the distance between the vertex to the focus and the vertex to the directrix. Recall that the distance from the vertex to the focus and the vertex to the directrix are equal, or it is equidistant. So here 4C is negative 4. But then, since we are talking about distance, we need to take the absolute value. Since there is no such thing as a negative distance, distance is always positive. Now, dividing both sides by 4, so dividing by 4, dividing by 4, that means to say that C is 1. Meaning the distance from our vertex going to the focus is 1. Now, since the graph is opening downwards, our focus is located at this certain point. And the coordinates of that certain point is, that's 0, negative 1. So that's our focus. Since the distance from the vertex going to the focus and the vertex going to the directrix are equal or is equidistant, meaning our directrix is this certain line. Take note, the directrix is not a point, that is a line, because by definition, a parabola is the set of all points that is equidistant from a fixed point and a fixed line. Okay, so since that's a line, we can denote the directrix by y is equal to 1. Why y? Because it passes through the y-axis. If it passes through the x-axis, so the equation will be x equals a certain number. But since it passes through the y-axis, so our equation of the line is y is equal to 1. Next, let's try to determine the axis of symmetry. Recall that the axis of symmetry is the line perpendicular to the directrix, and it divides the parabola into two equal parts. So in this case, since our vertex is at the origin, our axis of symmetry is x is equal to 0. So why x? Because it passes through the x-axis. This is our axis of symmetry. So if our parabola is opening downwards, if that's our vertex, the axis of symmetry is that certain line. So here in this certain example, our axis of symmetry is simply the y-axis. Okay. Next, let's determine the two endpoints of the latus rectum. Now again, recall that since our latus rectum is 4c, the whole distance, meaning from the focus going to one side, that's half of the latus rectum, and going to the other side is also half. So 4c will now be equal to 2c, which is equal to 2. Again, instead of using negative, we use positive because there's no such thing as a negative distance. So from the focus, we count 2 units to the right, that's 1, 2. That's one endpoint. And 2 units to the left, that's 1, 2. So the coordinates are, this is 2, negative 1. And the other coordinate is I'm sorry, this is negative 2. This is negative 2, negative 1, since it's on the third quadrant. This one, this point is 2, negative 1, since it's on quadrant 4. Now graphing the parabola, let's just connect the points. So this is the graph of the parabola x squared, or the equation of the parabola x squared is equal to negative 4y. So again, first determine the vertex. As soon as you know the vertex, plot that here on the Cartesian plane. Determine the focus. Then since the distance from the vertex going to the focus and to the directrix are equal or equidistant, so you'll also be able to determine the equation of the directrix. After that, determine the axis of symmetry, and lastly, determine the endpoints of the latus rectum. By the way, this is our latus rectum. So for any questions, again, feel free to comment your questions on the comment box or the comment section, or you can also send your questions in our group chat for me to be able to answer your queries or your questions. Now, let's talk about rewriting or transforming equations of parabola to standard form. So for the parabola, we have 8 equations in standard form. So again, if 2 or the exponent 2 is on the variable x, this one, this one, this one, and this one, that means to say that the parabola is either opening upwards or downwards. It is opening upwards if 4c is positive. It is opening downwards if 4c is negative. So this graph or this equation, the graph is opening upwards. Same with this one. Here, the graph is opening downwards because 4c is negative. The only difference is that for these two, these are located, or the vertex is located at the origin, whereas the vertex of the graph of these equations, the vertex is not at the origin. For the remaining four, if the exponent 2 is on the variable y, that means to say that the parabola is either opening to the left or to the right. It's opening to the right if 4c is positive. So the graph of this is opening to the right. Same with this one. So that's opening to the right. And here, since 4c is negative, the graph is opening to the left. Again, the only difference is that for these two, the vertex is located at the origin, whereas the remaining two, the vertex is not at the origin. Let me give an example. So we have 3y squared is equal to 24x. So how do we transform this one in standard form? Let's try to look at the examples or the given equations in standard form. This one looks like this. Y squared equals 4cx, right? So in order for us to transform this equation into this form, make sure that the coefficient of the variable y is 1. So how can we do that? We need to divide both sides of the equation by 3 in order to remove the constant 3, and the remaining constant or coefficient will be 1. So dividing both sides by 3, we will have y squared is equal to 8x, because 24 divided by 3, that's x. So this equation is now in standard form. So that's so easy. Next, for number 2, let's have this one. X squared plus 6x plus 8y equals 7. So take a look at the exponent 2. It's on the variable x. So let's find a way that this equation will look like either this one or this one. So how can we do that? Let's first arrange the variables. So it will look like this: x squared plus 6x. So group all the x's together. The remaining variables and constants, move that to the other side of the equation. Remember that if you're moving a certain number from one side of the equation to the other, do not forget to change the sign. So since 8y is positive, if we move that to the other side, that will become negative plus 7. Next, we will do completing the square. So I don't know if you can still remember, but we already did completing the square when we were converting equations of the circle into standard form. So if you forgot, this is what we need to do. So consider the coefficient of the variable x, which is 6. So divide that certain coefficient by 2. And whatever the result, you need to square that certain number. So that is 9. So we add 9 on the left side. Whatever number we added on the left side, we also add on the right side to balance the equation. Now we factor. So since this is a perfect square trinomial, the factor of this is the square of a binomial. How do we do that? Look for the square root of the first term, which is x. Sine of the second term, that's positive. Square root of the third term, that is 3 close parenthesis squared. So this part, this left side of the equation somehow looks like this, right? Now we need to simplify also the right side of the equation. So that's negative 8y, 7 and 9, that is 16. So we're not done yet. So copy the left side of the equation. If you take a look at this term and this term, they still have a common factor. So we need to factor that out in order to simplify the equation. Here, the common factor is negative 8. So dividing both terms by negative 8, we will have y. Because negative 8y divided by negative 8, that's y. Then 16 divided by negative 8, that will give us negative 2. So this is now the equation in standard form. Let me give you one last example. So example number 3, we have y squared minus 12x plus 8y equals 40. So earlier, the exponent 2 was on the variable x. Now it's on the variable y. So let's look for a way for this equation to look like this. So again, same process. Group the variables y all together. Earlier, since the exponent was on the variable x, so we group the variable x's together. Now it's y. So y squared plus 8y. The remaining terms, move that to the other side of the equation. That's 12x. Why? Because that's negative. If you move that to the other side, that will become positive. Then copy 40. After arranging the terms, proceed to completing the square. So y squared plus 8y. Consider the coefficient 8. Divide that by 2, that's 4, square 4, that gives us 16. Equals 12x plus 40. Whatever number you added on the left side, you also add that to the right side. So plus 24. Simplify. Look for the factor. So again, since this is a perfect square trinomial, the factor is the square of a binomial. Square root of the first term, y. Sine of the second term, positive. Square root of the third term, 4, close parenthesis, square. Simplify the right side of the equation, that's 12x. I'm sorry, the given was negative 40. Let me just correct that. So that's negative. So negative 40 plus 24. I'm sorry. Let me just correct myself. Since we added 16 here, we need to add 16 on the right side. Sorry, my bad. That's it. So negative 40 plus 16. Again, we're adding 16 here. Sorry, not 24. Why did I write 24? Anyway, since we added 16 on the left side, we also need to add 16 on the right side. So negative 40 plus 16, that is negative 24. So further simplifying, so look for the common factor. I think it's obvious that it's 12. Divide both terms by 12, that's x minus 2. So this is now in standard form. So that's it for the parabola, graphing, and rewriting the equations into standard form. Again, if you have any questions, feel free to drop it in the comment section below. Thank you so much, you guys. You take care. Bye-bye for now.